What if I tell you that the Earth and all the other planets in our solar system were once just tiny specks of dust floating in space? That you and every material you can imagine are made of stardust? Imagine a single speck of dust. Now multiply that by 1,000,000,000,000. This is the amount of cosmic dust particles that fall to Earth each year. This image might be hard to grasp, but it's the reality of the cosmos we inhabit. Cosmic dust is everywhere, omnipresent like a celestial mist that permeates the universe. It's not just in the far reaches of space, but right here in our own backyard, sprinkling down on us like a silent snowfall. So where does all this cosmic dust come from? The answer lies in the stars. Stars that have reached the end of their life cycle, dying stars, are the origin of most cosmic dust. In their final throes, these stars expel their outer layers into the surrounding space, creating a rich mix of elements. This stellar material cools and solidifies, forming tiny particles of dust. Each year, our planet receives approximately 40,000 tons of this cosmic dust. That's equivalent to the weight of about 20,000 average-sized cars, all made of dust, falling on our world annually. But cosmic dust is far from ordinary. It's not like the dust bunnies you find under your bed. Cosmic dust is a complex concoction of minerals and organic matter. It's a microscopic universe brimming with a wealth of elements: iron, silicon, carbon. These are just some of the constituents of cosmic dust. But even more fascinating is the presence of organic compounds. Yes, you heard it right. Cosmic dust carries the building blocks of life, scattered across the cosmos by the death throes of stars. So, cosmic dust is everywhere, even falling on us. But how does this dust create planets? Earth, the other planets in our solar system, and even those in galaxies far, far away started their journey as cosmic dust. Yes, that's right. Those gargantuan celestial bodies we marvel at started out as minuscule particles floating in the vast expanse of the cosmos. Let's delve into the process. The birth of a planet begins in a molecular cloud, a dense and cold region of space teeming with gas and dust particles. As these particles drift through space, they encounter one another due to the inherent force of gravity. This leads to the formation of a protoplanetary disk, a flat, rotating disk of these gases and dust around a newly formed star. Over time, these particles stick together, growing larger and larger. They form what we call planetesimals, the building blocks of planets. These planetesimals continue to collide and combine, growing in size until they eventually form protoplanets. Gravity plays the pivotal role here. It pulls together the cosmic dust particles, causing them to collide and stick together. It's a bit like rolling a snowball down a hill. It starts off small, but as it rolls, it picks up more and more snow, growing larger and larger. The protoplanets then undergo a process of differentiation, a fancy word for a sort of cosmic baking process. Under the immense heat and pressure, the heavier elements sink to the center, forming the core, while the lighter elements rise to the surface, forming the crust. Over millions, even billions of years, these protoplanets cool and solidify, becoming the planets we know and love today. From the rocky terrains of Mars to the gaseous swirls of Jupiter, each planet is unique, a testament to the extraordinary journey it has undertaken from cosmic dust to celestial body. So from infinitesimal particles to colossal celestial bodies, cosmic dust truly plays a stellar role in planet formation. Cosmic dust doesn't just create lifeless rocks floating in space, it may have also played a role in sparking life. Yes, you heard it right. The very dust that paints our night sky has the potential to be the seed of life. This is not just an abstract idea, but a hypothesis backed by several scientific theories. One such theory revolves around the idea that cosmic dust could have delivered the essential elements for life to Earth. You see, cosmic dust is not just simple dust, it's a cocktail of elements, including those fundamental to life, such as carbon, nitrogen, and oxygen. Some cosmic dust particles even contain water locked away in the form of ice. Imagine these tiny specks traversing the cold vacuum of space, carrying within them the seeds of life, ready to be planted on suitable planets. Now let's move on to something truly fascinating: the presence of organic compounds in cosmic dust. Organic compounds are complex molecules that contain carbon and usually are associated with life processes. The discovery of such compounds in cosmic dust particles suggests that the building blocks of life could be widespread in the universe, not just limited to our little blue planet. This leads us to the panspermia theory. Panspermia proposes that life exists throughout the universe, distributed by cosmic dust, meteoroids, asteroids, comets, planetoids, and even spacecraft in the form of bacterial spores. This theory, while controversial, gives a whole new perspective on the role of cosmic dust in the grand scheme of life. So, the next time you look up at the night sky, remember this. The tiny twinkling points you see are not just stars, but a cosmic dust storm, each particle potentially carrying the key to life's existence across the universe. From dust to life, the journey of cosmic dust is truly a cosmic saga. Whether it's creating planets or possibly seeding life, cosmic dust plays a more significant role than we ever could have imagined. Researching these tiny particles can provide big insights into our universe. Delving into the mysteries of cosmic dust is like piecing together an intricate jigsaw puzzle of our universe's history and future. Scientists have developed ingenious methods to study these minute particles, with each discovery shedding light on the grand cosmic narrative. A significant source of cosmic dust research comes from meteorites, those celestial objects that have made the interstellar journey to our planet's surface. Scientists keenly examine these space travelers for dust particles, which are like time capsules from the cosmos. By analyzing the chemical and isotopic compositions of these particles, researchers can glean insights into the processes that occurred billions of years ago in distant stars and nebulae. Yet, we don't solely rely on the meteorites that happen to fall on our doorsteps. We've taken the initiative to venture out into the cosmos ourselves. Enter space missions like Stardust, a remarkable venture that was specifically designed to collect cosmic dust. Launched in the late 20th century, Stardust's mission was to fly close to a comet, capture dust particles in its aerogel collector, and bring them back to Earth. And it was a resounding success. These samples, the first ever brought back from a comet, have provided us with invaluable data about the early solar system. Studying cosmic dust doesn't just quench our thirst for knowledge about the universe's past, it also gives us a glimpse into its future. These particles play a crucial role in the formation of new stars and planets. By understanding the characteristics of cosmic dust, we can predict and model the processes that lead to the development of new celestial bodies. So, as we continue to probe these minuscule particles, we're not just studying dust, we're studying the seeds of stars, the birth of planets, and the very fabric of the cosmos itself. So, the next time you wipe dust off your table, remember it could be a tiny piece of the universe's history. And if you like this explainer, we believe you would also enjoy the video shown on your screen right now. Click on it and let's catch up there.